So, where were we? So you're
So
going to move your hand.
I think you said it's going to move.
Hit the dot, if you want to hit, hold on. If you want to hit the dot, and all that's happening, you're still going to move your hand in a straight line, right?
Correct. I'm going to aim right at that dot, and I'm going to move my hand straight to the dot, and it's going to go straight there and hit it.
You can't do it. You can't do that.
Yeah, I can. Yeah, I can.
No, you won't. You won't hit the dot.
No, you will hit the dot.
You literally can't hit the dot. It's impossible.
All right, I made a demo for this. It looks like you got four.
Like the guy, bro, you're like Jeremy, the guy on the
you're so special. You got like 4 Coriolis demos that Glover's made for you.
Remember when you tried to throw the ball at the guy and it didn't hit the guy, it hit somebody else? Remember
Correct.
that?
Yes. Yep, I do remember that.
If you go straight, you're not going to hit the dot on the edge of the target. You can't do that. You just said
but the difference is
impossible to do what you said.
The difference is that the guy on the rotating platform, when I throw the ball, it doesn't have a rotating medium around it in which the ball moves in lockstep laterally with the medium.
Yeah. If you could go straight and still hit your thing, then you don't have the Coriolis effect going on. Then there's no Coriolis.
If the thing is, if you're moving,
Coriolis veers you off your straight line path, bro. It's literally impossible to do the thing you said if there's Coriolis happening. I'm just letting you know that.
Well, I think there's some. I think there is truth. I think there's some truth to that. It's why I say, like, to start with, we say, let's frame this as we're moving in perfect lockstep with the rotating atmosphere. The rotating atmosphere already, because basically, if you're moving with the atmosphere, then you're already getting pulled in that direction. Like, you're already having that. The tangential velocity being imparted on you by nature of being in lockstep with the medium. I think, though, in reality, like, a plane isn't gonna. A plane's not gonna.
Hold on, man. You're going way off course, bro. The thing you said you can do. No, the thing you said you can just do about going straight. The Coriolis effect will veer you off your straight line path, so you can't just go straight. You would get veered off. You would never be able to hit the dot. You cannot do that. That's why when they shoot bullets, they don't shoot where the target is. They make a Coriolis correction. You literally
I'm just sorry.
You said, like, we're not going to be able to get past this.
Okay, but hold on. Those
airplanes are not. Because that thing you just said, paid, we're having a 1v1. We're not going to get past this point because the thing you just said is not how Coriolis works.
Well, I know. Here's the thing, because you keep switching back and forth, right? If you're going to say we're talking about a thing like an airplane, because remember, it's a different conversation if we want to talk about a car driving north to south. If we're talking about a plane, hold on, the plane is moving in a medium, and it moves in lockstep with the medium, and the medium moves in lockstep with the record player or Earth or whatever is below it.
Yeah,
that's not the same as a ballistic, like as somebody shooting a gun. Right, because the gun has an inertia, and the bullet does not travel in lockstep. It does get like a little bit of a push, but it doesn't move in lockstep like an airplane does. Airplanes don't move. It doesn't move in exact lockstep, but it does move in the air.
Yeah, here's the thing, though. If you could do the thing you said, where you start off pointing at the thing and just go in a straight line and not turn left or right, that means there's no Coriolis happening.
But it doesn't move in lockstep like an airplane does. Airplanes don't move. It doesn't move in exact lockstep, but it doesn't move in lockstep like an airplane does. Airplanes don't move. It doesn't move in exact lockstep, right? Because the gun has an inertia, and the bullet does not travel in lockstep. It does get like a little bit of a push, but it doesn't move in lockstep like an airplane does. Airplanes don't move. It doesn't move in exact lockstep, but it does. Airplanes don't move. It doesn't move in exact lockstep, but it does move in the air.
Yeah, here's the thing, though. If you could do the thing you said, where you start off pointing at the thing and just go in a straight line and not turn left or right, that means there's no Coriolis happening. So in the example you gave of what you were going to do, that is impossible in the scenario where there is the Coriolis effect. So it's just not possible, bro. Coriolis throws you off your course. You can't go straight. That's why they have to correct for Coriolis when they fly planes, they say, because you can't go straight.
Yeah, I think part of it's because the plane doesn't, like I said, the plane doesn't travel in perfect lockstep with the atmosphere, and so there's a correction. They don't correct for Coriolis.
Of course not. It's flying.
They
do
just fly
correct for
it on a line.
Coriolis.
Here, I made you okay. Before we're done, you have to look at all of the Coriolis apps people made for you. You should feel really special today, and you have to judge which one's the best. This is important because this is for Glober rankings.
By the way, when I did mine, there was no AI system.
Yeah.
Yo,
Bacon gets plus. He gets times 300 for no AI.
Bacon gets negative 300. He almost talked me out of my leading the target argument with his bullshit.
And that's a negative?
Yeah, because my Coriolis argument now is rock solid, and you almost fucking talked me out of it. So you're way in the negative. Way negative.
I think that's
maybe the Globers could fight for a few minutes on which one's the best. Like who made the best demo?
I didn't see any. I've only seen Bacon.
Oh, mine is too simple. I wouldn't put mine on.
Bacon's is the worst.
Yeah, but he gets no AI like triple bonus points.
All right.
Jeremy, can you see the graphic?
I can't look right now. If you're on a rotating reference frame, if you're on a non-inertial reference frame, and you throw something at a point or someone or something, and the Coriolis effect is happening because you're on a rotating thing. If you throw it at them, you don't hit them. If you take off in a plane or anything and just go straight at them, you're not going to hit them. You have to go off of that straight line path that the ball or whatever makes to be able to hit the thing.
It depends on the inertia of the thing that you're throwing. It depends on the other forces that are acting on it.
Nope. Right. I think it's a basic Coriolis fact. Like, you're not going to hit the thing. If you hit the thing, there'd be no Coriolis. Then there's no Coriolis effect to account for, and there's no Coriolis.
Unless you hit the thing with a different path than the path that the inertial path, right?
You could lead the target and hit it, yes, but you wouldn't be able to throw it direct. You wouldn't be able to throw it directly at them, right, Bacon?
Yeah, that's why we say
Bacon agrees with me. Hold on, because Pfinky thinks he's agreeing with you and me at the same time, but he's disagreeing with me. He's going to disagree with me right now, thinking he's agreeing with you. But we agree. So this shit don't make. Now we got another love triangle going on, Pfinky. You see what you're doing to us here?
Yep. Yeah. I seem like I'm always involved in these. I say the same thing I said before. Coriolis is real, and the more inertia the thing has, then the further it's going to drift off course. But the more that it's carried by the object that it's traveling over, the less Coriolis effect you're going to see, and it'll approach zero the more perfectly it's carried.
Yeah, I mean, it's a balance between the inertia and the aerodynamic drag, right? That's why a balloon almost couples perfectly, right? And a bullet, a projectile, which is very high mass, very low drag.
Was that the end of the sentence?
Yeah, that's all. The airplane is a weird one because now you have an actively powered, actively steered thing, which is...
Yeah, I try to think of it like a glider. I try to think of it more like a glider that had some controls, but generally it just tried to keep its altitude high enough, and then it would do whatever, like crabbing, to stay in its path. It helps a little bit, I think.
Yeah, and it would have to, and guess what that glider would have to do? Because the only energy it has is its potential energy from its altitude. It would have to lose altitude at a faster rate to maintain the crab than it would if it didn't have to crab, right? So there's still energy that you're going to have to account for that's keeping it from being deflected.
The thing that everybody's forgetting is that this correction that we're all so worried about is minuscule. It's like 0.05 degrees at bank, I believe, something like that.
Yeah, it's like 60. It's equivalent to 60 mph of crosswind.
It says it's only like 14 miles an hour crosswind.
I'd say it's less than that.
Maybe it's different at the
If you're going 500, if you're going 500 knots, right? And then that's you know,
And the other thing is,
whatever that is.
airplanes are not ballistic objects. They've got these, two things sticking out the side to go up and down, and the big one in the back to go left, right. And then there's two big round things generally under the wings that are putting out a shitload of thrust.
Round things? Is that the technical term?
Yeah, round things. Usually they're round. Except you're near a 737, then they're kind of egg shaped, a little oblate.
Yeah, the thrust is kind of irrelevant though if you're not using it to direct it, right? If a bullet had a rocket motor on the back, but it wasn't used to steer it in any way, then it wouldn't change the Coriolis impact on the bullet.
They had those in World War II. They wanted to break some of this, so they had a bomb that would light a rocket to accelerate to go down, and they had to figure out how to drop it because it wasn't falling due to gravity. They did correct. It was interesting.
I think what would help me, I'm going to look this up, but I'm curious how much how much Coriolis is reduced by the plane moving through the atmosphere. It's probably different for different planes too, right? I would think some would be more.
Right. Yeah, it's going to be like if you look at something like a star, like the old F-104 Starfighter, right? That's very high mass, very low drag, very small aspect ratio, right? Compared to something like lightweight and floaty, right? Like a Cub, right?
Yep.
Something like a Cub would have basically would just be probably coupling basically 1-to-1 with the air mass.
Yeah, it'd also be like getting a hot air balloon and then just sticking a fan on the back to blow it, like not going to steer it left or right. It's just going to blow it in a straight line. And then thinking about it that way, like if you took that from the North Pole and then you just pointed it down a meridian, how far off course would it drift from Coriolis? I could be wrong, but I feel like the amount it's going to drift is going to be minimal because it's just
going to be pretty small. Yeah, it's going to be very small. Because the speed compared to its drag force, right, is going to make the faster you go, the less time force is applied to correct for it, right? So the faster that you're going, the bigger the Coriolis component will be.
Oh, that's interesting. I didn't think about that. That makes sense, though.
Not that much. I mean, if you think of a bullet that goes infinitely fast, there would be no deviation, right? There's no time for any deviation to take place.
Yeah, except there's no such thing as infinitely fast. I would just start.
Yeah, you get what I mean. Like the faster you're moving, the slower Earth appears to be. So the less Coriolis you should expect.
Careful with your words is all.
All right, Bacon loses 3 points for saying infinitely fast bullet.
Yeah,
well, I said if.
But here's the thing.
It doesn't matter. Okay, -2 because he said if in front.
Even if you could instantaneously transport the bullet from the equator to the North Pole, sure, it wouldn't be deflected at all because it moved there instantly. But assuming that it retains its inertia from the equator, the moment it rematerialized, it would be traveling 1,000 miles per hour.
Well,
right. But then it already hit the ground.
It didn't take any path from the equator to the North Pole. It just appears there. Like, come on, what are we doing?
No, that's not what I'm saying. That's what he said. What I'm saying is, what I said, if we could shoot it infinitely fast, which is not prohibited by Newtonian mechanics, because we're not going with Einstein here. We're going with Newton. All right. So Newton didn't have a speed limit.
Just settle on really fast.
Yeah.
Well, just say you're traveling.
If it can go from the pole to the equator at a millisecond or a tenth of a millisecond, Earth wouldn't have rotated basically nothing.
How long does it take light to do that? Not a millisecond, but all.
Yeah.
Kosho actually did the calculation before for light. For the
Light?
Coriolis of light, yeah. It's
I
there.
haven't thought of that. It actually
It's
makes
there,
sense.
bro. Yeah.
But I wouldn't trust the Kosho's math. He's got it wrong.
Of course. Of course.
It wouldn't be that much because light goes around
Why
the
is
Earth
he, by
7
the way?
times a second or something.
That was awesome, Jeremy. That was awesome.
So, I mean, here's the thing. You guys need to figure out what the fuck's going on. This guy, Josh, told me Josh Ingersoll, 2026, there is no reality. Do you guys agree with that statement, Pfinky? There is no reality?
There is only.
And then after that, he said, "Oops, there goes gravity."
So it takes 0.13 seconds to circle the Earth, so it'd be 0.06 seconds, or
Wasn't
6.5
that Eminem?
seconds.
Yo, Jake, you actually had one of the best. You actually had one of the best rap references I've ever heard in this. It was so good. I'll never forget it. You started telling this story. You're like, yeah, I was at college one time and my professor, asked how I was so good at this stuff. And you were like, I told him Socrates' philosophies and hypotheses can't define how I'd be dropping these.
Oh,
You
yeah.
let into it with
The
a whole
Wu-Tang?
story though.
Yeah.
That's dope.
Some good old Wu-Tang.
Yeah.
I might
But he
actually
let into
start
it
to
like it was a
Jake
real
if he
story and he
go
was at
Wu-Tang.
college. Go ahead, Rob.
I was just gonna say I would almost start to like Jake if he was fucking spitting Wu-Tang verses.
I don't even remember that, Jeremy. That's funny that you remember that.
Oh, I'll never forget it. Yeah, that was the best because you started it off like you were telling this story about how you were at college and you were talking about the professor, and it was like this whole long thing, and then you said that. I was like, oh shit, that was when I first knew you were 100% troll. Maybe not 100. You're like 99, 98%.
Like 76%, I'd say.
He's up there. Yeah, he's not. It's not. I over exaggerated, but he's up there. That
So
was the
you would have
moment.
to correct. You would have to correct 0.07 degrees if you had the light gun shooting from the North Pole of the equator.
Yeah, I think half the Globers in here would be flat earthers if it weren't for the ridicule.
Well, maybe if you had some evidence. I mean, you have any evidence today for the?
Oh my god!
I mean,
I have evidence, but you don't accept it.
What is it? What's the evidence you got?
Hey,
Straight
Rob,
lines.
do you mean they'd
No,
rather? Do you mean in some cases they'd rather dish the ridicule rather than receive it?
Well, dude, I have. It's funny enough. I have trolled flat Earth. Like, I remember we were at this overlook in Hawaii, and there were all these people gathered around at this overlook, and I was like telling my family, I'm like, look at the beautiful flat and stationary Earth that we live on.
Were you a silver? Weren't you a silver in 24/7? You made it up to like silver.
Yeah.
He still is. He's a gold right now, actually.
Oh, am I a gold now? Yeah, and I was a three question, whatever. That little token they'd give you for answering the 3 questions.
Let's be honest. If we were having a party, right, and we're like, yo, all the Globers are at this one party, right, across town, and then all the flat earthers are at this other party on the other side of town. Let's be honest. Which party are you going to?
Who's going to whose party?
By far.
Going to the flat earthers party. They party so much better.
Bacon, you even had a flat Earth party.
Yeah.
You know there's going to be better.
Exactly, Gio.
And there were no flat earthers. And it was
there's going to be. There's going to be more drugs at the flat Earth.
You were there.
Yeah, but the thing is, it'll be mostly just a bunch of podheads. It's not going to be the meth heads like the Glober parties.
Kind of in line with this.
I don't know, man. Have you ever seen? God, what was that guy from Globebusters? Can't remember his name now. The Morgile.
Yeah.
Morgile.
You got one.
I mean, you guys had the dude with the boob. You guys had the dude with the boobs. I'm sure he'd be a big hit at your party, right? Sean Hawkins' boy.
Shauna Hufford.
Yeah, that's your boy.
I was
He'll
I
be
was
there.
busting Red's chops about that the other week. He
might
got very
maybe
very irritated.
he might let you motorboat him or something. You never know.
I was asking him. I'm like, dude, so did you believe that story where he said he was in the army and he bumped his head on a Humvee and then grew giant cannons as a result? Did you really believe that story?
Jake making friends everywhere you go.
I've been staying away from Humvees.
Yeah, watch out for the Humvees.
Dude, every woman in America would be
Quick
driving
trip
around
to
in a Humvee with no
Transland.
helmet, dude. If that's what it took to grow giant cannons, dude.
Puts another meaning on a transmission on your Humvee.
Yeah, they would just have a surge. They would just have a procedure where they go like hit that part of your brain or whatever or something, and forget all the plastic.
Puts you on a mission to be trans. Hey, kind of related a little bit. I don't know if you guys are still on Coriolis, but this is just a random kind of thought I had. And okay, you know how people have their ideas, their worldviews. It's generally hard to like budge somebody from a belief or a worldview or a viewpoint on things because we have our egos, we have what we think is the evidence that we go with, all that, right? Well, the idea of like trying to convince someone that the earth is flat or trying to convince them that it's a globe, generally you're not going to like get tons of conversions out in the world. Like it takes people a process and so on and so forth. But I guess what I was going to say is it's the idea that like globe earth folks that are really into this conversation, like you don't have to sell them on being into discussing flat earth at all. Can you convince them it's flat? Probably not. Years and years and years, probably not going to happen. But you don't have to do any selling to get them involved in the convos. Like they're just naturally here. There's that funny meme that says, if you're lost in the woods, just start talking about flat earth and someone will come to debate it with you to like rescue you, like as a survival tip. As a survival tip. But I'm just saying, like the globe folks that are into talking about this, like you don't have to sell it to them. You don't have to. It was just a thought that came to my head the other day. It's like you don't have to convince them. You're not going to convince them it's flat, but you don't have to convince them to be involved in the discussions. It's like a natural attractor.
Yeah, because they all want us back on that globe because it's a globe. You gotta be on the globe, man.
You know what's so funny though, Gio? I've thought about it, and I've thought about it like this. Like, what if I actually was just this amazing convincer, and everyone I talked to, I converted into a glober? I thought that would be so fucking boring. It would all be a bunch of globers who'd have nothing to talk about. It would be like the lamest thing ever, right? It would be like your favorite movie, and then you get rid of all the conflict in the movie. It's like, who wants to watch a movie? There's no more conflict, right? Like there's no more antagonists, right? Like who cares?
So you're saying you're going to the flat earth? You're saying you're going to the flat earther party then?
Yeah, he is.
Of course, yeah, of course. What would I talk about with those fucking Glover people?
Yeah, but Jake,
you hung out on gems for about 5 years, bro. I don't know.
Oh no, I mean I still go in there. I mean, we have some interesting political discussions. We don't talk flat Earth in there though.
It doesn't always have to be about conflict.
People want it spicy. You know what I'm saying? Some people love the drama.
Yeah, because I asked my wife why she watches these stupid TV shows on TV, like where it's just couples bickering and shit. She's like, "Well, I have no drama in my life, and I just want to see what drama in life would be like." I was like, "You're fucking nuts. You enjoy some new TV shows."
What's funny is that like what Jake was saying in terms of like kind of trying to convince or convert someone kind of thing. Jake, like if every, quote unquote flat earther or anyone as stationary planar earth, etc., whatever you want to call it, if everyone that was in this just flipped to the globe, we all were like, all right, everybody just conceded and said, yup, it's a globe. It seems like the globe earthers would be like, wait a minute, come on, say it's flat. Like, come on, debate me.
Kosho already said if that happened. Kosho already said if that happened. Kosho already said if that happened, he would flip to being a flat earther to keep it alive.
I'm pretty sure also people on the globe side are less insecure about their beliefs. That's why they come into these types of conversations and aren't able to. I mean, compare that to like the flat earthers who never leave their home servers.
But what about those flat earthers that
What's
never
that got
leave
to
their
do with
home?
anything? No.
But
What's that got
they
to do with
talk to
anything? No, like
people in real life about it.
the Globers all coming here. So like, what's us leaving our home server got to do with anything? We said like a
That's the
2-hour
point.
thing. On,
That's the point.
And
I mean, Globers will go into any server, argue about their beliefs, but flat earthers, I mean, it's usually you'll hear them in their own servers.
I mean, I'll go
well, I don't
somewhere
have.
else. There's just a shit show everywhere else. Like we've managed to, we like changed the whole game for like talking about these things. I don't know if you know or not, but.
I mean, Jeremy, I'm sure you've been invited to stuff like Omni server back in the day, and all those other Glober servers. Or
Yeah,
the
but
last time you've been
why would I leave here? We're established. We've got things under control. Like, why would I leave here to go to like some new server?
That's the point.
I don't think there's any shame in having a home server. This is my home server.
I didn't say there was any shame in it. I was just Gio brought up why Globers don't need selling when they go into other servers or into these types of conversations, and that's why. I mean, that's just my opinion.
Well, yeah, you don't have to sell them to discuss it. Yeah, that's the thing. Like that does not need to be sold. Like folks will just show up to whether you call it defend or to, represent the globe position. And I think in some ways, I mean, this is kind of a deep topic because, okay, in some ways, there may be a variety of reasons, but there's one thing I've thought about over the years, which is if folks think it's a globe and then there's these other people saying it's not a globe, and then, not to go too far into like, oh, whether it makes them feel uncomfortable, not really going that route, but just if other people are saying it's not a globe, they maybe feel like it can't go uncontested. Like they don't want to let like just flat earth, as it were, just go out there and tell everyone and spread the word. They need to like have the resistance or the, not to just let it go uncontested, like kind of thing.
I don't know. I think that was a really interesting point that you brought up, Gio. I never really noticed that. I noticed that both sides, like you're not going to convince one side one way or the other, but it is interesting that you don't have to like get them to come and talk about it. It's interesting.
Yeah, you don't have to sell them at all on that. It's like a natural attractor, but you're not going to probably sell them that it is planar and stationary. Like that's very unlikely, especially if they're like someone who really is convinced it's a globe and then is debating it. Yeah, like they're
or works for a satellite company or something. Like you'd be telling them their job is like not real in some sort of way.
Well, yeah, and then if they feel like, like it needs to be, or they feel like they need to straighten the record, at least from what their point of what they think the record is. But folks saying it's not a globe are going to also feel like, hey, we got to straighten the record here. We're being lied to, kind of a thing. But
I know it's not till next map week's not till next week, but a map would go a long way.
That's not a thing. That's not a thing, bro.
Yeah, but Coriolis week this week, map week next week.
It's not expected.
Yeah, no, we'll give you a map. Yeah, no, but if we give you a map, the next thing you'll ask for is the model of how the map works, right?
Well, a few things on that.
Doesn't work. A map doesn't work in a way. It's just a map.
Then why ask for a map?
Well, because we can validate a map.
Yeah, it would.
How do you validate a map? With a model, right?
No, you just compare to things we know about reality, like how long it takes to get from A to B. That's I mean, if you get a very wrong map, you're gonna have some A to B points where how long we take from one point to the other would make no sense. That's why we never get one of those.
No, I hear you, dude. That's like the holy grail of the planar stationary Earth at this current time would be to have like, it's one of the holy grails to have the map. Just a few brief things. I know I often say this when the map's brought up, but number one, from the perspective that we have been lied to by the powers that be, it would not be expected that anyone who is either onto this or into this or whatever would have a map. Unless they unless they've independently mapped the whole Earth themselves, which would cost a lot of money. Could be done, maybe, but it would cost a ton of money. So it would not be expected anyone would have a map, first of all. Secondly, even if we had it or somebody had it and put it in the chat right now, a lot of people would probably just find holes in it because they already think it's the globe and they'd be comparing the globe to what the actual real, even if it's the correct planar Earth map. and they would have to validate it. So it's not like if someone posted right now, like to Pfinky or Bacon, that you guys would just go, there it is. Oh my God. There, like you would have to validate it, and you would probably find holes in it because you're already given the globe information. And again, you'd have to go out in the world and like match the soil to the map, you know, and that's, and basically now you're just making the map yourself. To validate it, you have to basically do what the original people did to make the map. You have to basically copy their work, and now you're just mapping the earth yourself.
And nobody's going to walk around with a globe because that would have to be your map. If you're on a globe, you can't put it on. Oh, wait. No, Red's Rhetoric said they did it. They glued a bunch of pieces of paper in the form of a sphere. Yeah. Yeah. We were just the other day talking about it. Red's Rhetoric said somebody took a bunch of pieces of paper and made a sphere out of them, and it was an accurate map. But that's the only way you're going to get a map that's right for your globe, is to actually walk around with a globe map. Who the fuck is going to do that?
I don't want to do that. Globes are too big.
Well, in theory, if it was a globe, hypothetically, you could have like a digital sphere, maybe, like in a computer system that would be your map.
Oh yeah, they got
Google, or like
Earth.
a photo. Maybe somebody could do a foldable globe.
Yeah, there's that funny joke that Issa says where like you're in an airplane and he like, I don't know, I forget how he tells it, but where maybe was it one of his friends that used to do it, but he like took a globe like up into the cockpit and he's like, when do we start using this to get around? I can't tell the joke as well as he did, but
use a beach ball so that way I can blow the air out of it when I don't need it anymore.
Dio, my thought on your point, I think your point's valid. We probably would pick it apart, but assuming it's a good map, it would hold up better than other ones. But my thought on like mapping the whole world is we already, like, everybody generally agrees that the way that the land is mapped onto latitude and longitude is correct. So it's really just a matter of testing distances between latitudes and longitudes to see how well they hold, right?
yeah, that's where the key is. That's where the difference is. Because if you have your azimuthal, if you have your hemisphere azimuthal grid of vision type thing, like like a planetarium, if you're in the middle of the planetarium, you're dead center, wherever your lat long is, which is the right ascension declination equivalent in the sky. So you have your right ascension declination in the sky, and then you're going to translate that to the latitude and longitude on the ground. You can say I'm at X latitude, X longitude, and pull it up in your planetarium, and you're right in the center of it. And then you can pull up another one, you're in the center of it. Another one, you're in the center of it. You can pull up 1,000 of them, and you're in the center of every one. But the question is that azimuthal hemispherical grid of the stars and so on, is that tilting and orientation as you move latitude and longitude to wrap around a sphere, or is it all coplanar? And that's really where the difference is like you said, between those latitude and longitudes, what is the soil, the rocks, the ground actually doing, you know, down to the actual measurement of the physical tangible distances, like you said, and whether there actually is that orientation, like plumb lines not being parallel, plumb lines diverging, which is the similar thing as the azimuthal grid. All the azimuthal grids are diverging from each other. So are they actually diverging, or are they coplanar? And like you said, those points in between them is where the magic is. You're hot, Mike and Rob. That's where the magic is between those actual points. And that would give the answer of which it is. If you could, you know, basically decipher that. But then you ended up mapping distances. Now you're actually just validating the Earth, which is not easy to do as a civilian without all the resources.
Well, are you guys aware, are there any places on Earth where the distances between latitude and longitude don't agree with what the globe says they're going to be?
I mean, dude, I haven't checked tangible distances other than just driving in my car. And so you're saying, are there any known discrepancies? Is that your question?
Yeah, I'm saying if there was a place on Earth where it was off by a lot, like say by 25% or more, I would think that maybe those people would start complaining about those. That would make its way up. You know, like people would be aware of it. I haven't heard of any.
Well, but you can get anomalies in GPS, and most people are using GPS. how many people are using like a trundle wheel or chains on the ground, or actually tangibly measuring. Plus, it's even difficult because the difference between globe and planar is more noticeable at the larger distances, obviously, like within a small section. And we can get into like plane surveying. All plane surveying is done generally within like 100 square miles. So 100 square miles is a pretty big distance, which that whole component that really curvature should be able to be measured within that. But even if we just leave that aside, the distances that you would need are pretty great distances. And so like if you were going to do 4 points in the United States, I think we've talked about like the 4 points, like making a square and then connecting in the middle, but between the inside the square with a straight line, that hole. And we've talked about like if you were to do it in the United States, like in Seattle, Washington, maybe down in Arizona or Southern California, another point in Florida, and another point in Maine, let's say. I think we've looked at some of the math to say that would be significant if you were to make a square with those 4 points. Now, I know people have done it with the stars, but then we're getting into the whole star situation. But anyways, let's say those 4 points would be enough to decipher between planar or globe. But I mean, who is able to tangibly measure the distances, even just between Florida and Maine, or Maine and Washington State, Seattle, or Seattle and California? I know you can get in your car and drive with your GPS. You have a road distance. I realize that can be done. And even if there is some discrepancy between what the GPS and your odometer shows, you can have like slippage in your wheels and friction and so on. But I'm just saying, like, to tangibly measure those 4 points, especially when there's so much private land, like you can't just walk freely over the earth with a trundle wheel. Hey, I'm going through your backyard, and it's a big project to do.
Yeah, my thoughts, like I'm kind of like go low res first, but you could just drive. You could drive north to south Australia, east to west Australia. You get a rough idea. Cars have odometers. They're going to be, they're not perfectly exact. I wouldn't, you know, whatever, but they're not like your odometer is probably not going to be 25% off. And then we could just establish like a general distance between things. I mean, I would use plane routes. It's maybe a little less reliable or whatever. But then we can just see just the general shape and size of continents. That would be a start.
Yeah, but I would say too, the thing with the road is that you have elevation, and then you get into the geoid and the ellipsoid, sea level, how sea level is established. So it does get more complicated because there's elevations that are given. And I know people just take elevations also, in a way, just take them on face value, but that is also a pretty difficult thing to confirm. I mean, you can do it with pressure, air pressure, but I'm just saying to get like the specific elevation changes in addition, like if you just drove across South America, for example, I mean, do you really feel like even with your car, you can do an odometer, but to really get like all the elevation changes and to make sure you have all that correct, I'm just saying even that would be quite a project.
Yeah, it would. I mean, you could track elevation, but you can just check, like when you're driving, you can see, does air pressure match whatever GPS says the elevation is, and that'll give you an idea if you're close. And we're just looking, like, I'm not saying to measure every continent. I'm just saying, are there places where there are anomalies? Because if the globe distances and all that are just wrong, then there should be a place where we can point and say, oh yeah, look, they're wrong consistently right here.
And certainly in the case of Australia, you need to have a map that accurately represents, the known dimensions of Australia. And it's quite easy to verify Australia because there are two major roads. One runs from Adelaide to Darwin, which is almost directly north-south. Another road goes from Adelaide to Perth, which is almost directly east-west. Both of those roads have very low elevation changes, and the distances do stack up with the advertised dimensions. And I can confirm this personally because I've driven both of those roads. They're about 2,500 kilometres in each direction. So that's a good indicator that the dimensions of Australia, as per the globe, are realistic.
Yeah, I wouldn't expect any of the continents to be dramatically off. Maybe Antarctica is an exception. It could be, but just because we have such limited access to that region. But Yeah, I hear what you're saying. I mean, I've driven across the United States and like several times in my life, and I don't have any reason to think that it's some like dramatically different distance or like that it's 25% off or anything like that. But when you talk about the difference between curvature and planar, we could get into the math, but it is significant at great distances, but it's less significant than you might think in terms of a trip like that, and being able to decipher the difference, especially if you don't have, tools. I was talking about like, could we use LiDAR if we build like a custom LiDAR system to measure
We go
distances?
2,500 kilometers. Now that 25 kilometers north-south would be a straight line, but wouldn't the east-west be an arc on a globe?
They're both arcs.
Yeah.
They're both geodesics, right?
Oh yes.
Yeah, one is
I'm not sure if I'm just wondering. But
one is a
like,
great circle route,
yeah, one would
which
be
would
a
be the
great circle
analogous.
route. The other one would not.
Exactly, yeah. One is an arc of a small circle. So like I have two types of circles on spheres. You have great circle
Yeah,
routes. You have great circles.
I'm just wondering how
And
that would affect the map look. You know, that you have to put on a flat piece of paper because you're not gonna put it on a sphere.
you can't put on a sphere. I mean, those are
Well, you
the
can, yeah,
globes you
you
see.
can, but you're not gonna walk around with it on a sphere. So how's it gonna look on the flat piece of paper?
That's why we have
Yeah,
projections.
and so it doesn't
The other thing you can do
actually
is
look like the projection.
What?
That yeah, it's not like the picture
I
you're
didn't
gonna look
hear.
at on the piece of paper is not gonna look the same as reality.
I mean, no map looks exactly the same as reality. Because it's a map. It's 2D.
Thank you.
When you fire an airplane, you don't see the names
Stop
of
asking
the
us
states.
for a map of reality.
Yeah, because if we're talking about a map that is accurate in distances, then the whole thing of like several points, depending on their distances, would only fit on a globe or a planar surface. So if that's the case, then the map would have to, ideally, if it's a correct map, it would have to be accurate. And what Rob's saying, I hear what he's saying. Like if you have a flat map and the Earth is planar, has that planar flat dynamic, then all the distances right from your map to the Earth, right back to the map, right to the Earth would all match. But if it was a globe, you really wouldn't be able to use flat maps unless, well, you'd have to distort them in some way. So then you're not getting a one-to-one.
Yeah, but like the smaller the section, the smaller the distortions.
Yeah, which is mostly what we do in our world is like deal with much like smaller local regions, like in cities or how many like civilians are actually able to measure anything that's beyond a local region that would have pretty negligible curvature, even if it was a sphere. That's what makes this a more complicated situation. First of all, you'd have to question the globe to even want to do these projects enough, and then you'd have to have the money to do it, and then you'd have to have the sort of strength to potentially expose one of the biggest deceptions in human history. So,
or you could just keep asking flat earthers for a map and a model.
That's more fun.
You guys just do it for us.
Yeah, I can use Google Earth and I can get around and get to where I'm going, and I'm okay with that. I don't have to believe that that's my reality on that phone that shows me where I'm going.
I guess what I meant by do it for us is if globe folks are like, oh, you think the Earth is planar and stationary, get us the map, get us the map. But if they're interested in the map, a planar map, then isn't it, I mean, I understand if someone else is asserting it, they're saying, hey, give it to me. But I'm just saying if they want that, then wouldn't they have to, well, I guess they could ask other people or they could seek it out themselves or they could try to map it themselves. But it is a little bit like, hey, you guys do this for me. Like if somebody who thinks it's a globe says, hey, I'm open to it being planar, can you show it to me? yeah, somebody else could show it if they had it, but they're kind of in a way like putting the burden on someone else. If they want it, then they're interested in it. They're seeking it. So I know they would say, "Oh, it doesn't exist, so you have to show it to me." But the alternative would be to go either map it themselves and then could show. Like if you mapped it yourself and you had some data that you could show, you'd be like, and if it did show a sphere, let's say, you could say, "Hey, here it is," and then you could present it, and then you could show how it is a globe, and then it could be replicated. That would at least be what would be needed for the globe. And I understand if someone's saying it's planar, you could say the burden's on them, or it could just be said the burden's on the person interested in the query in the first place.
How do you guys believe planes successfully get, say, from America to Hawaii without getting lost? Like, how do you think their GPS works? Surely they must be getting information somewhere of the true map, even if they're being tricked or whatever.
Their true map that's flat.
Whatever the true world is, like they successfully get to Hawaii. If they got lost, they run out of fuel, crash in the ocean, and die. Like, why would you ever go on a plane over the ocean if you believe?
I think they're just trying to make it ridiculous. We understand how planes fly.
Yeah, I'm asking flat earthers how they think planes navigate over the ocean and get to a tiny island in the middle of it. If they miss that, they're dead.
Is it Dead Reckoning?
They have coordinates that
they have a heading,
and then they put it into a GPS unit, and they follow the GPS unit to their destination.
Yeah, let's say they don't have GPS. Sorry.
So is Dead Reckoning to do with like stars and stuff? I forgot what that is.
No, Dead Reckoning, you have a position, a direction, you add those two, and you get a new position. And you keep doing that. And then errors accumulate, and then you have to fix it, then use the stars. But Dead Reckoning is just...
yeah. Well, Bacon, let me just ask you this in general as a generalized question, which is just taking it from your perspective. I'm just going to use the word if. So if the Earth is stationary and planar, do you think it's possible, even though you might think it's a small possibility, do you think it's possible that a planar Earth that could be represented as a sphere and sold to humanity as a sphere, but there could be, but do you think there could be discrepancies, and that it could be pulled off like a magic trick of sorts, or there would have to be, obviously anomalous components, but do you think it would be possible to sell to humanity essentially that it is a sphere, even though it is planar, if you had access to all the calculations and things behind the scenes to be able to do that? And I know your answer might be, no, it's not possible at all. But I will say, I mean, there is a historical relationship to these discussions. And in the future, if it all comes out to humanity and so on, that it is planar, we could go back to this moment and then see what you said.
I would say you can, but it would have to be something like a much bigger sphere where all the continents are just in a tiny section of it that is mostly flat. Then you could make those two very similar, to the point where maybe we couldn't distinguish between them. But the size that it's given to us, where basically have people in antipodal coordinates, I'm not sure how that would be achievable.
But is it possible, do you think? Even though you might not know, because then we'd be talking about, the military.
I don't know if it's possible. I can see how it could be possible. I don't see a way for it to be possible. I'm not saying it's not, but I just don't see it.
Yeah. Well, a lot of people, not to change the topic, but people think vaccines cause autism, and they're just slipping that right under our noses. So there could be big deceptions going on. And there's other ones that have come out to be, deceptions. But yeah, no, but not to switch to vaccines. I'm just saying they're, when considering what is the truth of some of these things. All right. So you're saying could be possible, but you don't know how. That's fair, because we're talking about if this is the case, and I'm just using the word if again, just to be neutral for everybody in the discussion. So if that is the case, then there would have to be, I mean, military intelligence of these countries that would be involved in it, right? There'd have to be a lot of money and a lot of coordination.
Sure.
And so, I mean, if it's an intelligence thing or like a magic trick, like, I know you don't think it is the case that it's planar, so I understand that you'd be like, okay, well, I don't know how they would do the magic trick. So I guess your answer is you don't know if it's possible because you don't know if it can be done or how it is being done, if it is being done.
Yeah, if I picture like the discrepancies between a flat Earth and a globe Earth, I'm like, if I would have to convince people that the Earth is a globe when it was flat, given like people can fly planes and drive cars and send signals and time them and do all this kind of stuff, I'm not sure how I would hide it in such a way that people wouldn't mostly notice it or easily notice.
But what about if the heavy reliance on GPS, especially when it comes to longer distance flights that would actually be able to decipher, outside of a margin of error?
But the issue is GPS agrees with your astronomical coordinates, which don't depend on basically anything, by a very tight margin. So there's not much room for GPS to be doing anything, smuggling anything. It matches too close to something that we can verify by ourselves, which is our astronomical coordinates.
Stars. See, that's where, I mean, we can do that, but we really need to do something to delineate instead of only extrapolating from the stars, because I mean, I certainly think the sky does have a spherical way that it functions. I think above a planar surface. So yeah, anytime the stars are starting to be referenced, we're getting into.
Yeah, but I'm not even like necessarily assuming stars are light years away and balls of plasma and all that kind of stuff. I can be completely agnostic on what the sky is and still establish my coordinates using them objectively. Which is why there is a flat Earth way to do it, right? I mean, not many people talk about it, but it's out there. No, there's a flat Earth model we can use to get your coordinates.
Well, I mean, I often refer to how, like in planetarium, you have that azimuthal grid, and all the stars are mapped to that. Basically, like in a planetarium, or when you pull up even in stellarium, like every hemispherical range of the sky can be mapped down to an azimuthal circle, a planar circle. So, I mean, the stars have been mapped on planar, because if you had all of the foundations, the azimuthal planar grids of all those planetariums, they could all be coplanar. But like I said, that gets into whether the orientation is tilting. But I'm saying, like, before the globe came along, humanity was already mapping the stars to a planar surface, right? I mean, do you agree with that?
The planar surface? I'm not sure I agree with that. But it doesn't matter much. Like when I'm talking about your astronomical coordinates, I actually mean something very simple. It doesn't require a lot of mapping. It doesn't require. You don't even need an almanac. So when you look at the sky with a time lapse and you see star trails, right? There's a portion. There's a part of the sky where star trails make a straight line. That's the celestial equator. So we can all see the celestial equator. It doesn't matter where you are. Unless you're at the North Pole.
Star trails are next week, Bacon. I'm just kidding. Go ahead.
Star Trail week.
Next week. Go ahead, Bacon. My bad.
Can't wait. No problem. Okay, so yeah, when you see this portion of the sky where stars are making a straight line, their star trails are straight. That's the celestial equator. So what we call zero latitude is simply wherever that celestial equator appears vertical. So if the stars at that portion of the sky are rising straight up and setting straight down, then you're at the equator. That's what we mean by the equator. So that's zero latitude. And if it's not vertical, then it's tilted. And the degree in which it's tilted, that's your latitude. That's what we refer to as your latitude in terms of astronomical coordinates. So that doesn't require basically anything. Like you look at the sky, see the paths that the stars are taking, find where they're moving straight, and just see how tilted that line is. Right? So that's your latitude. Now your longitude is simply the time offset between your sky and anyone else's sky. So if my sky appears half an hour sooner than yours, then I'm east of you. Yeah, go ahead.
Can I just interject real quick? The celestial equator is not our equator, my man. We use the solar equator with the sun.
I'm talking about something else. I'm just saying how you can get latitude and longitude without any almanac, any ancient data, anything. Like, you just watch the stars move in the sky. You can pretty much see what your latitude is, and then just get anybody else's observation and compare them. That's going to tell you the difference between your longitudes. And that's not something that depends on NASA or on Google Earth or whatever. That's like, it's just objective and easy for, not that easy. I mean, you need some tooling, but it's quite achievable without any extra sources, without any external sources. So
you definitely ballpark it with the naked eye.
Huh?
You could easily ballpark it with the naked eye. And even with if you had two different observations and a time and a way to tell the time, you could ballpark your longitude too with the naked eye. You might be off by like 10 or 15 degrees. You could be off by 10 or 15 degrees in each direction, which is pretty big. You'd be off by over 1,000 miles, but you would at least have a general idea. You would immediately know what hemisphere you're in. You would know whether you're closer to the North Pole or closer to the equator, and you would have some pretty general ideas about it, right?
Yeah. You can get all of that just by looking at Orion, because Orion pretty much tells you in which direction the celestial equator is, in which direction the north is, in which direction the south is. The whole thing's there. So you can see one constellation and already tell you what's your latitude with the naked eye. I mean, of course, with a couple degrees, but yeah,
you can even tell what month you're in just by knowing where Orion is in your night sky at what time.
That's only if you know where you are. But yeah.
No, it's the same for all locations on the Earth.
No, that's relative to the sun, because Orion is going to cross the sky during the night, so it's going to be in different positions along the night. So it depends on the time and the location.
The time of the night where Orion is directly due south of you is going to change throughout the year, and it's the same for all observers on the Earth. Well, they can see Orion, obviously, within the northern hemisphere and the southern hemisphere, where you can still see Orion. But
yeah, but like, if you don't know where you are, you have the same observation at somewhere else in a different time. So you can't remove the two variables and still solve the equation. You need at least two.
If you know the GMT time, and you know when Orion is in your sky, you would be able to calculate that out if you had some source for the GMT time.
Yeah. So you need the time. Wait. Only the time? Let me see.
That's like the only thing I can look up and be like, oh, that's Orion. Anything else, like, whatever, it's just a wash.
Orion is not. You agree that Orion is not visible in the summertime anywhere on Earth, right?
Yeah. Yeah, but here's the thing. Like, if you don't know where east-west is, and Orion's in the sky, you don't know if the sun is about to rise or if it just set. So I can manipulate the time and the date and get that match the GMT you have and Orion.
Well, if you've done a lot of amateur astronomy, you would know that like in the spring months, Orion is going to be high in the sky, due south of you. It's going to be later, and it's going to be earlier and later and later versus earlier and earlier, right?
Yes, but you only have GMT time, so you don't know if that's earlier or later at your location.
No. During local time, let's do the like let's say, I have to look it up and see, but like let's say Orion is going to be due south for all observers on the Earth on your local time around midnight, right? For all observers on the Earth. For all observers on the Earth.
Sorry, go ahead.
Yeah, for all observers on the Earth, given time, a certain time of year for all observers on the Earth, Orion's going to be due south at their local midnight, just like when the sun is like due south of you, right?
Okay, but if I have a local
every day,
if I have my local time and I have GMT, I already have my longitude, so I already know where I am. Like, you're adding an extra piece of information now.
Yeah. What I'm saying is you can use just like you can use the sun to determine your, like if you know your GMT and you just observe your sun, you can figure out your latitude, right? Because you can wait
Oh, my
to see when
GMT.
the sun. I'm sorry.
You mean
If you
my
know
GMT, my
GMT,
local time?
no. If you know GMT and you know when the sun, and you look at when to see the sun is due south of you when it's at its highest point in the sky, if you're in the northern hemisphere, assuming, then you can use the offset from the GMT time, and you could roughly calculate your longitude, right? Without knowing your local
Yeah, I'm a
time,
bit
just by
lost.
knowing,
I'm a bit
ju-
lost.
if
But I think you're
well,
adding more information now. Like if I
the
only
sun,
gave you, hang on, if I only gave
the
you,
sun is on the GMT meridian. The sun is at the GMT meridian roughly at 1200, right? Like roughly. Obviously, it changes throughout the year, right? Because of the orbit, but roughly speaking, at 1200 GMT, the sun is on the GMT meridian, right? So if you're
I'm lost
so if
again.
you wait,
Hang on. I think we're just boring everyone. But